Good morning, class. Today we'll be presenting on our smart room temperature controller. So this is a project that makes use of fuzzy logic to determine fan speeds of an air conditioning system or a cooling system using occupancy levels and temperature. The reason we chose this project was our collective interest in fuzzy logic, as this is a very practical model that is used in the real world. Things don't always operate on simply zeros and ones or on and off switches, but it depends on degrees of truthfulness or falseness of different functions. Fuzzy logic handles these uncertainties as said before. Now, fuzzy logic involves fuzzification, which is changing values into their fuzzy forms or degrees. This involves changing discrete or cryptic values into actual degrees for different functions. Then we have fuzzy rules. Fuzzy rules are if-then statements that guide the way systems operate. Then we have the fuzzification, which involves producing a numeric output after fuzzy rules have been applied.
For our methods, we imported our needed libraries. We then created our antecedents, that's the input and consequent output. We then created our membership functions for temperature, occupancy, and fan speed, using trapezoidal and triangular functions. Trapezoidal functions are used for ranges with gradual transitions, and triangular functions are used for ranges centered around a specific value. We created our rules for the antecedents and outcomes. We used our rules to build a fuzzy control system. We then validated inputs. We followed by fuzzifying and defuzzifying with the centroid. For the defuzzification, the centroid method turns fuzzy output into a single crisp output. We then concluded by generating the scatter plot.
Next up is the simulation of our project. User input is requested for the number of temperature and occupancy values as a positive integer. In this case, we are accepting only 5 pairs. This specification ensures that the project or the system gives at least one answer when run. After that, the input is then allowed for the different pairs. Temperature values can only be floating point integers from 10 to 40, and occupancy values are integers from 0 to 20, and this can be seen through the error handling as shown. The fuzzy control system then fuzzifies, and produces the respective output values, which is displayed as a table with its respective values. Lastly, the general variation of the fan speed and its respective values is represented as a 3D scatter plot and displayed. We found this plot particularly interesting because we later found out that the output values of a fuzzy system can never be extreme values due to the averaging effect of the method of centroid during the defuzzification. So in summary, fuzzy logic is an integral component in real-world control systems that makes up for the weaknesses of Boolean logic as our project shows. Thank you for watching our presentation.